Hello students, this is Shivam Mishra, starting polynomial lecture number 3. Now we will discuss about the zeroth of the polynomial. We will discuss about the zeroth of the polynomial. Before that, we would like to remind you that we have studied about the types of polynomial: constant, linear, quadratic, cubic, biquadratic, and one more heading we have studied: division algorithm, such as division algorithm of polynomial, by which we have known that division theorem or division algorithm: a equal to bq plus r, or px equal to qx into gx plus rx, or fx equal to gx into qx plus rx, in which we have studied that if remainder is 0, then qx will be the gx will be the complete factor of fx. Now we will discuss about the zeroth of the polynomial. Basically, we are going to discuss about the power 2 polynomial, quadratic polynomial. Quadratic polynomial. A quadratic polynomial is of degree 2, and if suppose we have an equation ax square plus bx plus c equal to 0, this is a power 2 degree 2 polynomial, because the variable has the highest power, degree 2, and a, b, c are constant. A, b, c are constant, and x square, x are the variables, are different form of variables, different form of variable, and x is a variable, Now more we will study what we have already studied that how to factorize this ax square plus bx plus c in class 9th by middle term splitting method. Here we will understand a new thing, what is called discriminant. NA and T, discriminant equal to D, it is represented by D, and D equals to b square minus 4ac. B square minus 4ac. We must remind you that b and a and c all are constant, which lies in the equation ax square plus bx plus c. B the coefficient of x, a the coefficient of x square, and c the constant term found separately. D equal to b square minus 4ac. This is called discriminant or D. And if we are solving a power 2 equation ax square plus bx plus c, it is of degree 2, so it will have 2 roots. If you are solving an equation, linear equation, it will have degree 1, so it will have only 1 roots or 1 zeros. If you are solving a cubic equation of degree 3, that means it will have a power 3 equation, it will have 3 roots or 3 zeros. Now some properties are there. If d greater than 0, means if by solving this b square minus 4ac, found that d greater than 0, it means that roots will be real and unequal. Roots will be real and unequal means what the value you are going to have of x. The value of x will be real value, it will have a real value, and that will be unequal, means both the values will not be equal to each other. Roots will be real and unequal. If you are having d equal to 0, that means roots will be real and equal. Real and equal, means both the roots will be equal. How can we say that roots will be equal? Suppose we have a method which we have studied, but we will discuss after a few minutes. Third part is d less than 0. D less than 0 means roots will be imaginary imaginary, and roots will be imaginary. That is not that we have to not discuss about this, because in the next class we will discuss about the roots. Imaginary roots, you will find that if the roots will be imaginary, that means d less than 0, discriminant value will be less than 0. If d equal to 0, roots will be real and equal. D greater than 0, roots will be real and unequal. What is the importance of d? How we are finding by d? Suppose we have a formula x equals to minus b plus minus under root में b square minus 4ac upon 2a, called Sridharacharya formula. Sridharacharya formula, Sridharya Sridharacharya Sridharacharya formula. X equal to minus b plus minus under root b square minus 4c upon 2a, and this is called the discriminant. B square minus 4c means the formula can be written as x equals to minus b plus minus d under root d upon 2a. If d value will be greater than 0, roots will be real. Value of x will be real and unequal. It will get two value, and both will be unequal to each other. If d equal to 0, means this value will finish it off, only minus b by 2a will be the result. Means d equal to 0 will give the result x equals to minus b by 2a. D equal to 0 will give the result x equal to minus b by 2a. Both the roots will be x equal to minus b by 2a. If d less than 0, means under root quantity will be less than 0. If under root quantity becomes less than 0, that is called the imaginary roots, and we cannot find the exact value of this function, so it will called as imaginary roots, and we will discuss it about it in the next class. Now next thing, we can have some more things, that is a relationship between the zeros and the coefficient of the polynomial. A relationship between the zeros and the coefficient of polynomial, and the coefficient of polynomial. Between the zeros and the coefficients of the polynomial. If suppose we are counting that if equation ax square plus bx plus c has the two roots, one is called alpha and another one is beta. One is called alpha and another one is beta. And then what we can write? We can write the sum of zeros or sum of roots, means alpha plus beta. What will be the value of alpha plus beta? That we can find with minus b by a. Minus b by a. Minus b by a means b is the coefficient of x. B is the coefficient of x and a is the coefficient of x square. Means we can write that sum of zeros alpha plus beta equals to minus b by a. Coefficient of x upon negative coefficient of x upon positive coefficient of x square, or coefficient of x square only. Similarly, product of zeros implies that alpha into beta implies c by a. Alpha into beta, product of zeros, implies c by a. That means that the constant upon the coefficient of x square. That means the constant upon the coefficient of x square. Again we will discuss. If we are having equation ax square plus bx plus c as a quadratic equation, it means that it has degree 2, so it will have the two roots alpha and beta. Therefore the sum of zeros alpha plus beta equals to minus b by a. Sum of zeros alpha plus beta equals to minus b by a, and product of zeros alpha dot beta equal to c by a. Now we will discuss about the power 3 equation in the next class. Thank you.